Hello everyone, this is Dr. Rajesh, and today I am again with you with my next video lecture. And the topic of this video lecture is direction of projection for a particle to hit a given point. So let us try to understand that what we have to do in this particular problem. For the same, let us say this is a line and this is another line, and say I'm going to name this as x-axis, I'm going to name it as y-axis, and say this is point O, and this is any point P, H, K, say given point which is to be hit by the particle which is projected from here with velocity u. So this point is to be hit by this particle, okay, and it is projected with velocity u, with velocity u, making an angle alpha, and this is the origin, and this is the given point which is to be hit by the projectile. So this is the given point. So everything is very much clear. The initial velocity of the particle is u, making an angle alpha, and with which it will hit the given point hk. We know that the equation of trajectory is given by, we have studied, is given by y is equal to x tan alpha minus 1 by g x square u square cos square alpha. So if we see this particle is passing through point h comma k, or say that this projectile is passing, this path is passing through this point h comma k, so it will also satisfy its equation. So since projectile passes to point h comma k, therefore it will satisfy its equation. So may I write here as k, at place of x may I write as h tan alpha minus 1 by 2 g h square u square cos square alpha. This is k is equal to h tan alpha minus 1 by 2 g h square by u square. 1 by cos alpha is secant alpha, so this will be secant square alpha. This is h tan alpha minus 1 by 2 g h square u square. Secant square alpha is 1 plus tan square alpha. So this can be written as h tan alpha minus 1 by 2 g h square by u square minus 1 by 2 g h square u square tan square alpha. Now this equation is quadratic in tan alpha, so making the coefficient of tan square alpha as 1. So for the same I need to multiply both sides by 2u square by gh square. So in the next step we are going to multiply. So may I write here as multiplying both sides with 2u square by g h square, and you may include minus so as to make this coefficient unity as 1. So this will also make it 1, so it will be minus 2u square g h square, here is k is equal to h minus 2u square g h square, here is tan alpha. It will be plus 1, it will be plus tan square alpha. This implies that tan square alpha minus h to h will cancel out, minus 2 u square by gh tan alpha plus 1 plus 2 u square k by g h square is equal to 0. So what we have done here, writing tan square alpha, writing this thing, then writing 1 and then transposing the side, it will become positive. I have written this one. So this will further imply that tan square alpha minus 2 u square gh tan alpha plus 1 plus 2 u square k by g h square. These are because constant quantity enclosed in the braces. So I'm going to name this equation as equation number 1. Now see, this is quadratic in alpha, tan alpha. So if it is quadratic in tan alpha, then it will have two values of tan alpha, and in turn it will have two values of alpha. So therefore we can have 2 points of projection to for a projectile to hit this particular point. Say one, it can be projected with angle alpha 1, another with alpha 2. So if I say you have to hit this point, so there are two direction. One, it can be done from that way, another it can be done from that way. There are two directions. Say this is making angle alpha 1 and this is making angle alpha 2. So this can be done in two ways. I have shown it that it can be done in two ways because it is quadratic in tan alpha, therefore it will have two values of alpha. So this I have written that quadratic in tan alpha, it will have two values of alpha, therefore there are two directions to hit a given point, that we have to show. Next, in the same article we have to prove that there is some least velocity at least with which it is to be fired. Like if we have to hit this particular point p h comma k, then it cannot be like it will be thrown with very small velocity, it will not hit. There is some particular minimum or least velocity with which it has to be fired from this point O, so has to hit this particular point. So we have to calculate that particular least velocity so as that it hits that particular point. So that least velocity we have to calculate. Next we are going to calculate the least velocity for a particle to hit a given point. So this we have to find least velocity for a particle to hit a given point. Now once again see the point that I am trying to discuss here and make you understand that this equation number 1 will give that direction along which the particle should be projected so as to hit the point. So say this is the direction it should be projected. Okay, so for this direction, only for this direction, this will hit the point, and there are two such directions. Okay, other direction will be imaginary direction. If it will have some other roots, then it will have the unreal direction. That will be imaginary roots means unreal direction. I'm going to interpret this physically, that imaginary roots of this equation number 1 will give the unreal directions along which it is not going to hit the particle given point. So if I say that for this to hit the given point, the direction should be real. If I say direction should be real, so its root should be real. For its roots to be real, we know that discriminant of this equation should be greater than equal to 0. We know that discriminant is equal to b square minus 4 ac, that should be greater than equal to 0. Now come from equation number 1, we take the value of b, a and c. So b will be minus 2 u square gh whole square minus 4 into 1 1 plus 2 u square k by g h square should be greater than equal to 0. Here a is 1, b is minus this one I have taken, a is 1 and c is this one. So this further implies that this implies that 4 u4 upon g square h square minus 4 minus 8 u square k by g h square greater than equal to 0. This implies that u4 minus 4 taking g square h square as LCM. So this will be minus 4 g square h square minus 8 u square k into g. This implies, and here is also 4. This implies that 4 will also can be written as something like that g square h square. This is u4 minus g square h square minus 2 u square g should be greater than equal to 0. Now you see here, for this to be greater than equal to 0, this factor is also always positive. So this will always be positive. This factor has to be greater than equal to 0. This implies that we can write it something like implies u4 minus g square h square minus 2 u square kg is greater than equal to 0. This implies that u4 minus 2 u square kg greater than equal to g square h square. This implies that u square, I'm going to make it as whole square. This is 2 kg dot u square is greater than equal to g square h square. So I have to make it as a perfect square. For this I am going to add half of the coefficient this of u square. I'm going to add and subtract. So this will be 2 kg dot u square plus kg square minus kg whole square is greater than equal to g square h square. This implies that u square minus kg whole square minus k g square is greater than equal to g square h square. This implies that u square minus kg whole square is greater than equal to kg square plus g square h square. This further implies that taking square root on both sides minus kg greater than equal to k square g square plus g square h square, and here is the square root, implies u square is greater than equal to kg plus k square g square plus g square h square. This implies that least velocity of projection, because it is greater than equal to, for least u square should be equal to, for least u square should be equal to kg plus k square g square plus g square h square and the square root. So this equation number 2 will give the least velocity of projection for a projectile to hit the given point. So we have determined the least velocity of a projection, that is given by relation number 2. Now next we will find the times of flight to hit a given point. For an example, if I say this is the point, okay, and we have studied that this point say h comma k, there are two directions too, like this is the direction number 1 and say this is the direction number 2. This is making an angle alpha, this is making an angle say beta to hit the point phk. So it will have time of flight say t1, it will have time of flight say t2. So we have to determine that what are the times of flights for that projectile to hit the given point. Okay, so now next is to find the time of flights to hit a given point. Now we know that horizontal coordinate, that abscissa, is given by, in case of a projectile, this is given by u cos alpha t. We have already studied these two formulae. This is u sin alpha t minus half gt square for point h comma k, say point p. So we have h in place of x, k in place of y. This implies that h u cos alpha t, and it will be k u sin alpha t minus 1 by 2 g t square, and this is going to be named as 3 and 4. Here see, h and k are given, so these are constant quantities. U we project it with the at least velocity. U is a also known, so we project it with initial velocity, say u. So u is known. So for time of flight to determine, this alpha could be variable because we have studied there could be two directions. So for two different directions, this t could be different. So alpha is a variable quantity. So from equation 3 and 4, we need to eliminate alpha. And to do so, what shall we be doing? We shall be writing it as k plus 1 by 2 gt square is equal to u sin alpha t. Now scaling and adding 3 and 4. This will be h square plus k plus 1 by 2 gt square whole square is equal to u square cos square alpha t square plus u square sin square alpha t square. This is further equal to u square t square cos square alpha plus sin square alpha is equal to u square t square. This implies that I am going to open this square. This will be k square. This will be g square t4 by 4 plus it will be kg t square is equal to u square t square. This implies that this can be written as 4 h square. I'm going to take LCM 4 plus g square t4 plus 4 k gt square is equal to 4 u square t square. This further implies that, so I'm going to first write g square t4. So this implies that g square t4 minus it will be 4 u square t square plus 4 k gt square. Both terms containing t square are written. Then we are going to write plus 4 h square plus 4 k square is equal to 0. This implies that g square t4 it will be plus gk minus u square, and 4 is taken out. This is t square and this is plus 4 h square plus k square equal to 0, which is quadratic in square. So say it has two roots. Say it has two roots, t1 square and t2 square. So this implies that sum of the roots formula is minus b by a. So this will be minus 4 gk by u square and a is g square. So this is equal to 4 u square minus gk divided by g square. And again we know that product of roots is equal to t1 square t2 square is equal to c by a 4 h square plus k square by g square. This implies that t1 square t2 square is equal to 4 h square plus k square by g. Now see, we again consider the coordinate. This is x, this is y, this is the given point h comma k, and say this is hit from the projectile at point from point O. So say the time of flight for this is t1 and another hit is something like this one, and for this time of flight is t2. So if we say this is hk, so if I say I join it from here to here, this is the radius vector, the position vector. So in this case, this is k, this is h. So I say what will be op square is equal to h square plus k square. This implies that op is equal to h square plus k square square root. So if here I put the value of h square plus k square, it will be op square. So I'm going to put the value for op square by g square. This implies that t1 square by t2 square is equal to 4 op square by g square. This implies that t1 t2 is equal to 2 op by g. Therefore, the product of two flight of times should be equal to 2 times the position vector of point P divided by the value of G. So that product should be equal to T1, T2 should be equal to this one. So if one time of flight is known, then from this relation the other time of flight could be known. So this is how we have determined the time of flights for the projectile to hit a given point, and there are two different directions to hit a given point. So there are two different time of flights we have determined. So in this article we have studied that what are the different parameters for a projectile to hit a given point. So this is all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. Very soon I will be with you with my next video lecture. Till then, take care, bye bye, thank you very much. This is Dr. Rajesh saying goodbye.